Okay, here what they're asking us is to find the inverse algebraically. Okay, using algebra. Okay, and the way we do that is just like we did with the relations, but we switched our x and y. So let's do that here. F of x is y. So if this is y, now we're gonna make that an x, and then those x's are now y's. So y minus 1, y plus 2. Okay. Now that we switch it, our next thing to do is to solve for y. Okay, so first of all, when we have a fraction like this, especially if your y is down there in the denominator, you're going to want to multiply both sides by your denominator. That's how you get rid of any fraction. Multiply everything by the denominator. That will get rid of your fraction. These are the algebraic tools that I'm telling you that you have to remember from everything you went over in Algebra 1 and Algebra 2. It's a lot. Okay, so if I multiply both sides by my denominator here, then I can cancel my denominator out because anything over itself is just 1. Okay, so I'm going to rewrite this, and I have y plus 2, x equals y minus 1. Okay. What do we do next? I would do distribute, right? Let's distribute this x. Because look, I'm trying to isolate y, but I have two y's. That's when it becomes a little difficult because you're like, wait, how can I combine if it's inside of parentheses? It's restricted. It's kind of like when it's inside a square root. I can't just pull out a y underneath the square root. I can't just do that. I have to get rid of the square root first. So how do I get rid of this parentheses here? I do that by distributing. Okay, so I get y times x plus 2 times x equals y minus 1. Okay. Now let's move stuff around. Let's get the y's together. Okay, let's get the y's together. Now I have a negative 1 here on the right side. Before I move this y, x to that side, let's move that negative 1 so that we can isolate the y. So let's try to get y's on my right. Okay, so let's add 1. Let's add 1 to both sides. Okay, and then I get yx plus 2x. And then we have a plus 1 at the end. And then just one y to the right. Okay, again, we're trying to isolate the y's. So I'm going to bring this yx that's on the left. I'm going to bring it to the right side. And remember, if we subtract here, if we were to divide and just bring the y, right? Say, you know what? I just want to bring the y, so we're going to divide everything by y. That's just going to complicate things a lot more. Because that means you have to divide by y here, divide by y here for the 2x, divide by y to the 1, and divide by y here. It's just going to mess things up. So let's first move all of it. Okay? And once we move that yx, we're left with 2x plus 1 equals y minus yx. When you see this, especially when you're trying to solve for that variable, when you see two terms with the same variable, a little light bulb should appear in your head and be like, oh, let's factor that out, right? I have two terms that have something in common. They both have a y, so let's factor that y out. So y times 1 gives me y. Y times a negative x gives me negative yx. And I have a 2x plus 1. Let's move this a little bit Okay, one last step. I can isolate the y. You see how I cleaned it up? I started off with 2 y's everywhere, but now I got it down to just 1 y by factoring out that y. Last step would be, hey, let's move all of this. I have a y times 1 minus x. So we can move the 1 minus x by doing the opposite operation, which is division. So 1 minus x, 1 minus x. 1 minus x divided by 1 minus x, anything over itself is just 1. And I'm left with a y that's alone. Okay. Once you get the y alone, that's when we write f of -1 or the inverse function, okay, is 2x plus 1 all over 1 minus x.